Welcome to our only slightly delayed session on advancing technical and societal readiness in AI for climate. My name is David Rolnick, and I am a co-founder and chair of Climate Change AI, which is one of the organizations running this event alongside Reciprocal and 2811. And we're very happy to have you all here. This is the run of show. We're going to be talking about AI for climate today. And we'll start out by having a quick introduction, followed by 4 lightning talks. Then we will have some time for participatory discussion and brainstorming of actions, and we have some ways to really get the discussion going. And then we will have a bit of time for networking. Fantastic. So just to get the discussion started, let's talk about what AI for climate actually is. So Climate Change AI, we've looked into the overall space of AI for climate a lot, and I'm a computer science professor. This is what I do as well, with my other hat on. But this is a really big, far too detailed taxonomy of how AI intersects with climate action in lots of different sectors. You can't read all of this, but if you're interested, we have a whole 100-page paper on it. But suffice it to say, AI is relevant across lots of different sectors, from climate modeling to transportation, agriculture, forestry, and other land use, heavy industry, and lots of other things. But the overall themes that we see, this is the full report, somewhat obscured by the video down at the bottom, if you're interested in more details. The overall themes that we see for how AI can be relevant in climate action. There are a lot of different ways that AI can be relevant in climate action. If you're thinking of like one application, your favorite application of like AI can be helpful in this way, there are a lot more. There are 100 pages worth of different applications. And there isn't one like silver bullet, AI is going to fix climate change. There's a lot of medium scale ways that AI can help accelerate existing solutions. So the overall themes that we see are, first of all, distilling raw data into actionable information. You often see this in terms of remote sensing, satellite imagery, for example, remote sensing for monitoring, reporting, and verification, or disaster response. Some of you might have been at the talk earlier today by Al Gore and Gavin McCormick about Climate Trace. There you can see some of the Climate Trace data obtained through remote sensing and AI machine learning. The next theme, if the slides will cooperate, is in improving operational efficiency. There are a lot of complicated automated systems where AI can help a system run more efficiently, often using less energy. So this could be, for example, in HVAC systems, heating, ventilation, and air conditioning systems in buildings, and in industrial processes like in factories. So using less energy or less raw material can be a really good application for AI in these kinds of systems. Here's an example, BrainBox AI, which is a recently acquired startup that works on AI for building energy use optimization. Forecasting and lots of other things all at once. Forecasting, predicting what's going to happen next. For example, in the context of electricity supply and demand, the UK's national grid has used AI extensively in order to reduce overproduction of electricity and increase efficiency through predictions down to the minute and hour of how much supply and demand for electricity there is. That's, for example, from their partners at Open Climate Fix, which work together with the UK national grid. These are all deployed. And in general, most of the examples I'm going to bring up here are deployed. The fourth theme I want to touch on quickly is speeding up time-intensive simulations. Climate and weather forecasting agencies are already using AI in different ways to emulate portions of climate and weather models, speeding them up and allowing for higher resolution, or to literally increase the resolution of predictions through downscaling, and various other ways that AI is being used in speeding up these complicated physics-based simulations in climate and weather, but also in other contexts like in engineered systems like the power grid. That's a picture from the European Center for Medium-Range Weather Forecasts, which uses AI extensively in various of their data products. Now, the fifth theme, final theme I want to touch on is in accelerating scientific discovery. This, unlike the others, is at a bit more of an early technological readiness level. And the kinds of applications we're looking at here include discovery of new materials for batteries, catalysts, photovoltaics, and various other different kinds of breakthroughs that are needed in the energy transition. Now, across all of these, again, I want you to think of AI as not something that's futuristic. It's already being used. But there are lots of different readiness levels for different kinds of AI projects, and there's a huge need for scaling things up and also maturity of various different technologies that are just starting to be used. Now, before getting into the lightning talks and discussion, I do want to quickly touch on what we actually are meaning by AI in these and other use cases when we talk about AI and climate action. So what is AI? Well, AI, in the context of climate action, is blank. These are some examples of the kinds of AI that one uses in climate action. Remote sensing, time series analysis, machine learning for optimization, physics-informed machine learning. These are various keywords that refer to technical areas of AI. Now, these are not the same as what one often thinks of in the public imagination when one says AI. AI in the public perception is often chatbots, text generation, deep fakes, image and video creation, various different kinds of AI. These are both columns are AI. They're also both machine learning. AI and machine learning are both big buckets. They include a lot of different things. But in climate action, it's generally the things on the left and generally not the things on the right. And importantly, there are various other characteristics on the left and right-hand columns. On the left, these are actually a class of AI algorithms called classification and prediction algorithms. On the right, sometimes it's called discriminative AI. On the right, it's large-scale generative AI. These are not just different uses of AI. They're fundamentally different technologies. They just both are called AI, and they're both called machine learning as well. And importantly, on the left-hand side, because, again, of the nature of the algorithms and the way that they get developed, these are often collaborative and user-centered designs, whereas on the right, they're often designed in a top-down way and in a relatively problem-agnostic way. Rather than designing for a particular use case, maybe trying to solve lots of vague problems and maybe not solving any of them particularly well. On the left-hand side, again, importantly, because of the way in which these algorithms exist, the intrinsic nature of these algorithms, they are often scalable and intended for distributed use, whereas on the right-hand side, often they require massive resources, so large amounts of energy and large amounts of computational infrastructure in a consolidated way. So when people talk about AI has a huge energy footprint, they're right, but it's the right-hand side, not the left-hand side, which is fundamentally different algorithms, which are being used for different kinds of things. So it's important to remember that there are various different paradigms for AI because AI is this big bucket that it can refer to lots of different things. And these are the sort of big two buckets into which AI is falling right now. Okay, so with that, let's frame the conversation today. There are a lot of different families for action, kinds of levers that one can take to advance the innovation space in AI for climate. And we're going to be focusing on the space of capacity building in innovation, advancing the innovation ecosystem, which ties in with all of these other pieces of this pie, which is where you can see there's like a big happy family of different levers here, including also policy and regulation, community engagement, empowerment, advancing research, etc. And the particular themes for discussion that we would love you to bear in mind are first of all, thinking about socio-technical capacity in understanding the capabilities of AI. Sort of what we were talking about on the previous slides, building capacity and understanding where AI is relevant, what AI means in these kinds of contexts, and how it can be deployed. Then technical capacity for implementation and maintenance of algorithms, which is, of course, essential as the next piece, right? Alignment between climate action broadly and AI for climate so that one is slotting technological advances into existing solutions. Geographically relevant capacity and resources, not just having there be capacity in centralized places, but ensuring that this is tailored to the needs of particular communities and geographies. And thinking about innovation financing mechanisms specifically as one mechanism for advancing action. So with all of that said, I would like to hand the floor over to our first lightning talk speaker, who will be Dr. Maria Schwarz-Sosa, who is the Executive Director of Climate Change AI. The floor is yours.
you very much for the introduction, and I think I can start the lightning talks. Thank you, David, for the overview of the space of AI for climate and how some of these interplay with many other levers that we are discussing here at COP and more broadly in society. I will focus on two main ones. One is sort of the difficulties that exist still to actualize actually many of these strategies and use a lot of these technologies in the context of a climate action. And this is because it's still, we still have many prevalent data gaps, especially in Global South, and there are many places in the world that is very hard to collect these kinds of data. And so we have across, sorry, I'm fighting with the advancer to here. Okay, so we have various data gaps, both in climate science, in, for instance, power and energy grids, in biodiversity monitoring. So we have across climate science, climate change mitigation, and climate change adaptation, many data gaps like these ones. And so at Climate Change AI, to help understand better what these gaps are and facilitate how to coordinate efforts in this space to fill those gaps and, you know, eventually have other gaps to fill, because it's a never-ending endeavor. Next slide, please. We have started to map what these data gaps are. And we have started to do this effort for a subset of sectors. For instance, here we can see that we have some in weather forecasting, others in building energy models, others in climate simulations. And so we have this for many more applications and use cases of AI for climate actions. But what sort of was one of the major contributions of starting to think about how we think about data gaps was that, next slide please, is that we were able to think about the taxonomy to distill what are the issues with the data in the end. So in some cases it's a wish, the data doesn't exist at all. In other cases it's the reliability of the data. In other cases, the obtainability of the data is just not easily accessible or findable. In other cases, it is insufficient, so it requires additional data collection that sometimes can be onerous, or in other cases, it can actually be simulated. So other kinds of gaps are also in usability. The data may exist, but might not be easily usable by machine learning algorithms yet. And so there's the issue of machine learning readiness of the data that is available as well, that is onerous part of this process as well. And then there's other miscellaneous challenges that exist as well, and this is a growing taxonomy as well as we continue to map out these data gaps. Next slide, please. One of the things that we have done at Climate Change AI, because it is an emerging field, is try to bridge some of these data gaps in our ecosystem. So we have run an innovation grants program specifically designed to build open data sets and tools that then can catalyze further work in the community. And so this includes projects all over the world in many areas of climate action. Here I have some examples on material discovery, on building energy, optimization. We have some on mangrove restoration, others on benchmarks for monitoring verification, as well as others on adaptation to floods, as well as others related to climate risk projections in small island states, for instance. So these are just some examples. We have ran this program for a few years, and so fantastic. Thank you so much. Our goal is that over time these data sets start to be increasingly used. In addition to our Innovation Grants program, an effort that we have been doing to mobilize also the philanthropic sector, the public sector, has been to try to map out some grand challenge initiatives in AI for climate and nature, and identify, as David highlighted in the previous talk, what are some of the levers that are essential in the development of this work. And in the various interventions that you'll see today, we will highlight different initiatives and different considerations that interplay into what then sort of results in successful applications. But we can see that overall in the space there has been, particularly since 2017, a steep increase in sort of like the interest in initiatives. These can be hackathons, crowdsourcing initiatives, grand challenges, moonshot challenges, prizes, grants, all of these kinds of initiatives to, in many cases, accelerate early stage solutions. In other cases, accelerate the technology readiness level of these solutions as well. Yeah, but we can see that we still have a big chunk of it, of these grand challenges still centered on Global South, and a very small portion of these initiatives actually focus on Global South specific initiatives. So there is a big equity gap in AI for climate, and there really needs to be a big mobilization for this. Now for the next slide. I would like to highlight a few initiatives that have existed. So the Microsoft AI for Grants, Earth Grants, has run for 5 years. It was a 50 million commitment over 5 years that has run. There's the AI for Development Africa. That is an initiative that has had a first phase until 2024, and now is in its second phase. So it will go at least until 2029. It's not just focused on AI for climate, so it is focused on creating several research hubs and capacity building within the sub-Saharan Africa. So there's some hubs that are focused on health, others on gender, others on cybersecurity. There's one on climate as well. Now there's one on language as well. So it has sort of like multiple vectors. There is our innovation grants program. There is as well like the Lacuna Fund call for data sets in machine learning for climate. It also focuses on data sets for language as well more recently, but it has had calls on energy, on forests, on agriculture that have created new data sets specifically in Global South and data scarce ecosystems. There was also the Mozilla Technology for Fund cohort on open source AI for environmental justice last year. Next slide, please. And there have been some bigger grand challenge initiatives like the Google.org Impact Challenges on Climate, the XPRIZE Grand Challenges like the XPRIZE Rainforest that ran last year. We have more recently the Bezos Earth Fund Climate and Nature Grand Challenge that is a $100 million initiative that started last year and will run for a few years as well. And there's also the initiative of the Manchester Prize as well. So I think I'll stop here. Maybe, so, yeah, I think this is my last slide. Yeah, and you can go back. And now maybe I can do the handover for the next speaker. So yeah, next up we'll have Dr. David Dow that will join us, and I'll let you introduce yourself.
Thank you, Maria. So we will see with this. I'm excited as much as you guys are. But yeah, I have also a couple of slides. I will take 5 minutes of your time, 2 of which I'm speaking, 2 of which I've prepared a video from the communities that I work with. and I hope so much tech goes well. Let's see. I'm David Dow. I'm the co-founder and chief scientist of Gainforce.Earth, and our goal is to decentralize nature research and finance. Next slide, please. So we talked about data gaps, but I want to be very clear. In fact, it's quite simple to see because biodiversity itself, all the data is stored in a database, a single database from the collection of Alexander von Humboldt's first data point in South America to now. And my question to the audience is just very simple. How much do you think the world's biodiversity data, land-based, was measured in? Oh, thank you for revealing the answer. Yes, so 82.23% of all the data ever collected in biodiversity is actually just collected in Europe and North America, leaving just 17.57% to the global majority. And next slide. Even worse, of all the data, only 0.5% is from the Amazon rainforest. So next slide. If you display the amount of data proportionate, the world would look like this, right? This is the opposite map of nature. This is actually more like a map of GDP than it is of biodiversity. So in fact, there's a saying in artificial intelligence research that says, garbage in, garbage out. So when you train your models with this data gap, then you will result in horrendous biasly algorithms. And actually, in fact, we published several papers in the past years to show that this is the case in the carbon credit marketplace, where you estimate wrongly carbon credits, or even in places such as foundation models, where you have data, but much of the local data is still biased. Next, please. So we want to solve this. So in fact, how we do it is we try to work with local communities. The last thing we want to do is we want to be a top-down approach, and we want to collect the data from like a centralized entity in Silicon Valley. I think the solution is working with local communities. And Gainforce, since the founding of the organization 3 years ago, we scaled through solely a trust-based organic level to 53 local indigenous communities around the world, many in Brazil. In fact, we work in Manaus, in Rio Negro, and the Amazon area. And our goal is to collect that data, not from a top-down approach, but from a bottom-up approach, by building capacity on the ground, collecting data like here, Diego with his little drone, or the indigenous community in Inhabe that we're teaching how to collect canopy maps, or here in Santa Helena doing glass, which is in the north of Rio Negro. Okay, it's really important to get the values right. So how we run as an organization, we are non-profit, and that's for a purpose, because we are not discriminating, we are not compromising on our values, which is community first. It's not about the data points, it's not about machine learning algorithms, it's not about, in fact, the animal species. For us, it's about the nature stewards, the humans that are protecting the forest. So we work closely with local champions, and in fact, the local champions that we empower are the ones that are holding the workshops. We are techno-local, meaning that our infrastructure is deployed locally on the ground. In fact, we are purchasing several kind of like small computers, like Mac Minis that we deploy in these communities with a Starlink, and they collect the data locally, and they're connecting into a decentralized network where they decide, number 3, data sovereignty, if they want to share the data or not. In fact, we are innovating on a principle of data governance inspired by the indigenous communities on a council. We call the Data Council or Nature Guild, where we have every year an election of all our communities deciding a representative of the region that then decides the data policy. And here you can see the wonderful, this year's Nature Guild Data Council reaching from Uganda, India, Brazil, Malaysia to the Philippines. And we're very proud of this concept. Next slide, please. So the idea of data collection is connected to the idea of climate resilience through funding. We despise the idea of a carbon credit-based system that is top-down, where you have to pay upfront $500,000 to create a carbon credit project. What we do instead, we build new software that you can issue an impact certificate, but of course no one's going to buy your impact certificate if there's no impact data connected to it. And that's why, next slide, we're connecting monitoring and data collection with a system called EcoCerts that has so far, since the launch of it in January, raised more than $30,000 to 50 communities around the world, completely bottom up, simply by the donor coming to the website, clicking on one of these certs, see that there's data collected, cool, I buy it. And that's how we are fundraising and skipping the carbon credit-based system. Next. Lastly, I promised you I wanted to talk only 2 minutes. It's been like 4 or 5 now. But most importantly, I want to bring some of the voices from the communities that we worked with. And that's why I prepared a small video for today, how to close my talk. So this video is about a community in Manaus called Inhabe, that is Satarima Vitikuna. And we've been working with them last year for the X-Prize Rainforest very closely to co-design the technology. And we ended up winning one of the prizes of the X-Prize last year. And the bonus prize for strongest community collaboration. And actually in a couple days we're going to announce that we are donating this whole prize to fund an indigenous scientist endowment fund that finances indigenous communities. So yeah, that video would show it if the video will be shown.
Fico muito feliz com toda essa equipe maravilhosa para mostrar toda essa tecnologia, que é uma grande oportunidade, principalmente para nós jovens daqui da aldeia, para principalmente preservar tudo que a gente tem aqui, ficar de olho, né, através dessa tecnologia, até mesmo de atividades ilegais que possam estar ocorrendo aqui dentro da nossa região. Eu quero muito poder aprender a pilotar o drone, a ter todo esse conhecimento, né, e também para poder proteger a nossa aldeia.
Para mim está sendo assim uma reviravolta na minha vida, mas eu aprendi com a minha equipe que o cientista é aquele que procura a ciência, é aquele que procura suas respostas. E eu estava em busca das respostas e eu consegui encontrar no meio da ciência, no meio da inteligência artificial.
O mundo possa enxergar e conhecer um pouco mais do que é a aldeia Inhambé, o que é o nosso território, a parte que nós somos bem tradicionais também. E através da inteligência artificial as pessoas podem ter mais acesso à ancestralidade, conexão, né, com a fauna, com a flora, que qualquer pessoa em qualquer lugar do mundo estiver acessando, nós possam conhecer sim a aldeia Inhambé.
A gente nunca soube exatamente o que a gente tem de biodiversidade aqui dentro da aldeia, né? E trazer assim a tecnologia de vocês é mais uma aprendizagem pra gente, né? Porque a gente não entende muito bem, mas com o ensino de vocês, repassando e conhecimento, repassando para nós indígenas, nem todos fazem isso. Quando eu vejo que as pessoas têm um bom pensamento e quer transmitir alguma coisa boa pra gente, a gente aceita de coração. Quantas árvores estão em pé, então olhando de cima como se fosse um satélite, olhando lá de cima, né? Mas só tá vendo o verde ali, não tá vendo aquelas pessoas que estão ali debaixo das árvores, né? Que somos nós, os animais. Então a gente consegue ver dessa forma, a gente vai estar preservando o que a gente tem de bom ainda.
To introduce Dr. Thank you, first of all, David, for the persistence on getting the video on. I think for who doesn't speak Portuguese, and the subtitles were very, very small and couldn't grab a shot of the QR code, please come talk to us. It's really worth a watch. And without further ado, I introduce Dr. Lorena Hayatieri to the stage to talk to us and about another initiative.
So first, no slides, no surprises, just the end of the surprises at this COP, getting used to again to this word called Berlin, and now code for whoever not used to. This is when you get into a room, it's very, very cold, and we go outside and we enjoy the heat. So I'm here as I'm a long-time researcher on the political economy of AI, and most of all, I'm a long-time investigator of the history of internet and what we call now agents. I've always been human-computer interaction, sci-fi, this was my thing. But from a very, very early age, I come from a rural family. I have grown up some ways, like very close to big trucks, being like close to a family that has been handling like small agriculture and being like very close to climate change, I come to think of social technical systems and the communication between agents and how it was changing our life as society. So as you see, I'm on the policy space now. This is kind of like, yes, and it's, but what I really love to do is to keep the conversation going for science, technology, and innovation, right? I mean, coming from the science technology studies field, when we are talking about climate action and land use, as an advisor to the Green Screen Coalition, and I'll talk more about the Green Screen Coalition, is how can we think about the future of innovation, yes, and how can we think about the Global South, but not this very like rigid, or as we sometimes put some boxes, like this is the global majority, the Global South, and not sounding like, yes, we really want to think about innovation, but we have communities being impacted. And I think David was really good showing that when we are looking to AI, and as I was saying, the history of agents, it's a very diverse history, the history of technology. So I come from looking into how this history has been shaping how technology is appropriated by communities. So in Brazil, I have a long time work with indigenous communities, traditional communities, what we call the riverine communities, on how they are creating their own way of producing data, and we are calling citizen-generated data. So addressing these gaps that Maria was talking about, right? I mean, we have the official data on emissions, but what about the data on the biodiversity and the biocultural lives of communities? So this is something, for example, that I have been closely working with archaeologists. We have archaeologists using, for example, now using LiDAR to look into the past, but always with the communities. The traceability of the history is also with the communities. So that's what I came here to talk a little bit. And I came like after all these great slides, and I think the whole social technical arrangements that we are looking into when we have to monitor, report, and verify what our countries are actually saying they are doing. But then we also want to check with the communities if this information is real in terms of not like truth or false, but have they participated in the process of creating platforms or creating new tools, like the ones that David just showed. Like these tools, they are part of people's lives because they are producing co-construction with the communities they serve. So this is another feature of my work. I work for the communities, always with them. So how we design, how we bring design justice as a feature for these platforms, because they are going to interact. Agents talk to each other, right? They facilitate even other conversations. And I think this is very key for the work that ClimateChange.ai and the work that David does with the partners in Brazil, is to understand that when machine learning is acting on something, it's actually changing the environment as well, and humans are operators in this process. So the Green Screen Coalition. So the Green Screen Coalition is a coalition of funders, practitioners, and even like research institutes, but it's a way to bring closer these different silos that we have been noticed for the past 10 years at least, the digital rights space and the climate justice space. And maybe even more broad, like when we are seeing the way that the movements are changing COPs, like in terms of looking into forestry, looking into like how land use is also like so important to have the communities being part of these conversations to defend their territories. So at the Green Screen Coalition, we work commissioning research, looking into how we can build communities more stronger to deal with the impacts of technology, but also being part of the solution, identifying the problems and building the solutions they need, they assess they need. So I just want to bring a few examples that we are looking into, not in the slides, I'm going to talk about it, is that how we are looking into different ways that we can, for example, looking into this gap of data, right? So one of the work that I have been doing with the green screen is to look into strategic fits that are actually building this symbiosis between climate justice organizations and communities, and also other organizations that are part of, for example, of this space. And then we have, for example, initiatives like climatechange.ai. So we are calling these strategic fits, at least 6 that we have identified at the Green Screen Coalition. One of them is community digital infrastructure for climate justice. What does this mean? It means that if we don't have internet and meaningful connectivity, as we have the information from UNESCO, we need at least 60 megabytes for people to be able to develop initiatives by their own on education, health, the minimal connection for services that they actually need. So what we have been focused is how to identify how this can be support for environmental governance, right? So how these infrastructures for connectivity are actually this medium way to harvest deforestation, to protect their territories. So we are trying to understand, like, what is exactly the next step after meaningful connectivity exists? Because it's not about connectivity. That this is not the whole issue. So this is one of the key strategic feats that we have identified. Another one is monitoring transparency and territorial data autonomy. We know it's very important for the NDCs, the emissions that we report, but then the communities, as we see at the Indigenous Caucus, they are also part of spaces. They are developing their adaptation plans. We have Sineia Wapixana, for example, indigenous woman from Brazil, that have developed their own indigenous adaptation plan in Roraima. So we have many examples from the Global South that communities have been doing community-led systems for forest monitoring, counter mapping, using, for example, OpenStreetMap to map illegal activities. So these are all forms of producing data in the community. And what we are looking into, how we can combine with interoperability. Because what we are identifying as well is that we are facing issues with the communities that are gathering data, and also, for example, not being able to communicate with the appropriate institutions to follow up on the illegalities. Another strategic feat is community-led innovation and appropriate technology itself. We look at how rural and forest-based communities are already prototyping context-specific tools. And nothing better than David's example on how it's so important to look into context-specific needs. One great example I bring here is the tool that IPAN, an institution from Brazil that looks into forest monitoring, and COIAB, the indigenous organizations of Brazil, they are developing the platform SOMAI for 10 years already. It's a platform of geomapping for the indigenous groups. So each indigenous group works with IPAN to develop the maps and the layers they need for mapping the traceability and the change seasons of food. So it's not just about illegalities, for example, it's also a way on to look into how mapping the traceability of how they walk through the territory has been changed through the years. And this is a sign of climate change because they do need to change paces to look for food, for example. So this is innovation for survivor, for endurance. So this is something else that we see as a strategic fit between the digital rights and the more broad technological initiatives that we see with the climate justice movements. Another strategic fit are obviously how digital data and environmental justice global governance has been working. So it's a strategic fit that we have here that, for example, how we can come to these spaces and collaborate into the negotiations room, traditional communities, indigenous people, and be part of the conversations about technology. Another one are the foundations of AI and green transition, and how we look into the impact of AI at mass scale, just like David shows. And lastly, I think, this is it. Thank you, everybody, and I invite you to read the report. Thank you so much.
Thank you so much. I want to keep on listening to all the different aspects of your analysis there. I'm sorry that we are so pressed for time. We have one more lightning talk from Mr. Waldo Soto Bruna, who is co-founder and director of Reciprocal and 2811, who will be joining, I believe, virtually. Do we have you there? Excellent. We can see you and hear you and see your slides. It's all yours.
Hello, everyone. Really happy to be here. Greetings to the team there. Thank you to all the technical team behind this to make all this possible, so we all can connect. I couldn't join in person this time, connecting from Berlin here. Yeah, it's a pity I couldn't join, but anyway, the technology is making it possible. And thank you again for having me here. So briefly from my side, I just want to emphasize a couple of points here to maybe close the conversation or close the insights that my fellows before share, mainly around the opportunity we have to produce some of the solutions we need with AI and technology from the region, for Latin America and the Caribbean. After our research, we just published assessing a bit more than 700 solutions produced in the region on nature and climate. And also, I would like to share, and maybe this can open the conversation for later, I would like to share also with you some gaps, of course, there are always problems, some gaps that still persist in the region if we really want to enable new solutions in the space. So the climate crisis, I think this is something you know already, but really to solve it, we need not just local solutions happening or in deployment, but also we need exponential innovation. And this is the point where the technology works. The technology works on our side, you know, because the crisis is so massive, it's interlinked with so many other crises that really to solve the big picture, the end game, we need exponential innovation. We need to make soon incremental also improvements at the local level, but also exponential innovation globally. And the region, Latin America as a region, together with the Caribbean, holds unique assets for this. We have biodiversity, we have a huge potential on energy, we are close to crucial ecosystems globally, but we are facing still underdeveloped ecosystem for innovation and for technology production in the region, something I'm going to share with you in a bit. Before going for technology for climate or AI for climate, we have to think where the innovation or the technology is needed most in the region. No? We still need more innovation to amplify solutions around nature, around biodiversity and biotech. We still need to see more solutions from the region on blue economy technologies, the restoration of seas, the restoration of oceans is still a pending issue. We have a great accomplishment around the declaration of marine conservation, for instance, but still it's pending how we manage that, and technology then is very important for that. We have still, beside the efforts of many countries in the region, we have still huge space to improve on energy, storage, and of course, cities resilience and water management. Just to give you a feeling of like some fields interesting and where the innovation is needed the most in the region. So after this report, we launched it, I think was 2 months ago in the New York Climate Week, where we assessed solutions, scalable solutions, or startups, scalable solutions from different countries, where we see where the innovation is happening in a way. So, of course, Brazil, a strong arm on innovation in the region, but also we see many innovations, many solutions happening and being born in Mexico, Colombia, and Chile. Then, as a summary, like a very unfair summary of all this report, but maybe it can be helpful for the discussion later, we observe some advantages that the region has to develop, create, and deploy solutions for climate and nature. We see in different countries a strong ecosystem on like technology development ecosystem, mainly Brazil, Chile, and Uruguay. The AI readiness of some of these countries is compared to New Zealand or some regions, some in India, for instance. We have enough human capital. You compare with a country itself, the entire human capital in the region is very interesting. And the costs, in a way, of that human capital is sometimes can be 5x or 10x cheaper than hiring, I don't know, like a research in Denmark, for instance. We are close to crucial ecosystem, which enable us to pilot here in the region and then scale up. And we have a strong market maturity in many of the economies in the region. Again, this is a very, very overview of some of the insights we have, but I wanted to share that with you. There are many solutions happening already in region. You don't have to put attention to this, just put attention to game forest. Game forest is a great example of how solutions are being placed in the region and how the communities are very important there. But we have still a long way to go. I wanted to close with some capacity gaps we feel still are very present in the region. Capacity gaps or pipeline gaps, we see them as the problems that the project itself, the solutions itself, we have, meaning they are not ready still as proper projects, proper companies. The academic world is still disconnected from the solution side. There's a limited talent pipeline. You can think of where you will get the best engineers from a country, and it's still just a couple of engineering schools per country, which is very problematic. And the ecosystem support is very, very fragmented. And from the money side, and I close with this, sorry, over time. From the money side, from the funding gap, because we need money to produce the solutions, to deployment, to scale them up, we see still a scarcity of local money, local funds being deployed. There's a huge problem we are observing here on ticket sizes, like there are philanthropies or investors, funds coming into the region asking for projects starting in 10 million US dollars, when we see projects on the other side not being able still, many of them, the vast majority of them, not being able still of reaching that size of project, no? So there's a mismatch between the capital, what the money is looking for, and what the projects can manage and what the projects are prepared for. And then, naturally, this is a problem in the funding ecosystem in general, but there is a problem with the termism where everyone is searching for solutions for money, in the very short term, when solutions here are for later. Just I want you to close with this. It's so easy to get lost with startups, funds, and technology, but I think it's a good reminder for ourselves also that this is about regeneration, planetary health, and that all these solutions should be placed for that. Thank you.
Thank you very much, Waldo. Perfect. So we wanted to give opportunity of everyone to participate as well. So we know that there are other people in the room that also work on these topics, have interest in these topics, want to contribute to these gaps in or filling these gaps in financing, capacity building, implementation, and evaluation. And so we have Paul with a platform that enables people to see other contributions from people in the room, vote for them, also add additional contributions. But I will also invite people that would want to verbally contribute to the discussions to address either of these questions. I would start with the first one, if anyone would want to share any bottlenecks or barriers that they are facing in their context on either of these capacity building levers. It can be about the second one also, if that is something that people would want to weigh in on, that would be all right too.
Yeah, so I wanted to invite maybe the person, I don't want to single people out, but I would love to hear a bit more on the data colonialism, data colonization input, because there are so many great, terrible stories that one can tell. So if people want to share, feel free, but no need. We've also got lack of benefit sharing with communities as something that people have brought up. Does anybody want to expand upon that? Funding limitations, bottlenecking the scalability of technical upskilling programs. We have a suggestion from the speaker system. Academics being arrogant, not working with indigenous communities, extracting data. Project based upon a community validation is a project that will be sustained in the future, rather than one that's based upon extracting data from indigenous communities, I take it. Anybody wanting to expand upon some of these?
So I think there's a problem with data collection. So I work a lot with communities. I go on the ground, and when they see me, they're like, not again. They're like, another one, right? Because it's not like we're the first ones coming. There are past histories of data collection from probably well-meaning academic scientists, but then they extract the data, and you never come back because your grant ran out, your project finished, right? And I just want to emphasize what a magic it is to just return twice or 3 times and 4 times. That's all it takes to build trust. And one of the things I noticed when I was competing in the Express Rainforest competition, we talked a lot about indigenous empowerment, but actually when you looked at the teams, the finalists, of the finalists that were like 10 finalists, not a single one except for our team signed a benefit sharing agreement with the communities. And they were just using the communities, talking about them, sometimes not even bringing them to the events. And I think there's a big difference also at COP between talking and doing. And I think this is really important to remember.
That's a really, really great intervention. And I come from the AI community from places where people also they don't even go out and collect data. They don't even do extractive data collection. They hope that somebody else has done all that work, because that's not considered to be like real AI work. So if you think about the AI researchers, they're often even one more step removed from extractive data collection. They're not even doing extractive data collection. I mean, maybe that's a bit of a weird way to put it. Moving on to other suggestions in the suggestion sharing system. Money is still flowing to big name organizations. Does anybody want to expand upon that? Okay. This should be a sharing. Talk about the things that you've shared. I'm not seeing more statements, but do other people want to contribute to the circle? Well, should we wrap up? Or yeah, I think that people are probably eager to end another long day at COP. Thank you all for coming. It was great to have you here. Please feel free to mingle in the few minutes that we have left before the hour and meet other folks who are interested in this area. Thank you again. And thank you again to our great speakers.